Hello guys, I hope you are good. Welcome back to my channel. Subscribe to get more content on maths. Today we wanna continue from set theorem. We'll start from complement of a set. Given that a set A, the complement of A is written as A prime. A prime means a complement of a set. Complement. What do we mean by a complement? A complement, it is the element in the universal set that are not in A. For instance, e.g., we have a universal set represented by U as the following element 1, 2, 3, 4, 5, 6, 7, 8 are within a curly bracket. Set A is written in method intension X such that X is an even number less than or equal to 6 within a curly bracket. Set B is such that X is such that X is odd number less than 7. Find A prime and B prime. We'll start by listing the element in set A and the element in set B. The element in set A, X is such that X is an even number and less than or equal to 6. An even number. We'll start with the element 2, even number 2. Then the next even number will be 4 and the next one will be 6 because it was less than or equal to, which means we'll start from 6. Then you write it within a curly bracket. Let's list the element. Since we have listed the element in A, we can now find the A prime. From our definition, a complement of a set, then the complement of a set A. The complement of a set A is it's the element in the universal set that are not in A. The element in a universal set, 1 is not in A, start by 1, it is not in A, 2 is in A, 3 it is not in A, 4 it is in A, 5 it is not in A, and 7 it is not in A, and 8. These are the elements in the universal set that are not in the set A, and this will be our A prime or A complement of set A. Let's go to B. B will start by listing the element of a set B. Element of a set B, X is such that X is an odd number less than 7 which will not write the seventh one. Odd number will start with 1, 3 and 5. We will not write 7 because it was less than 7. Then we write it within a curly bracket. These are the element of the set B. Then we'll proceed to write the complement of the set B. From our definition of a complement set, it is an element in the universal. These are the elements in the universal set that are not in the set, our set B. In the universal set we have 1, and 1 is in the set B, so we will not write 1, we will write 2, 4, 6, 7 and 8. These are the elements that are not in the set B, but they are in the universal set, and that's how it's being done. Relative complement or different of a set. Let's handle this. Given that two set at A and B, the difference of a set is given by A minus B or B minus A. A minus B means that element in B that are not A minus B means that element in A that are not in B. This means that element in A that element in the set A that are not in the set B. A minus B means that element in the set A that are not in the set B, while B minus A means that element in B and are not in A. Means that element in set A in set B that are not in A. For instance, e.g., we have a set A. Set A contains the following elements: 1, 3 and 5. Within a curly bracket, set B 1, 4, 2. Within a curly bracket. Find A minus B. A minus B, that means that element in A that are not in B. We have A minus B. Element in A that are not in B. Element in A but they are not in B. 1 it is A and it is B, so it's not a complement. It's not a complement. 3 it is in A but not in B, so we will write 3. 5 it is in A but it is not in B, so we will write on 5. These are the A minus B. Then we need to find again, this was Roman 1, Roman 2, B minus A. B minus A, what does it mean? It means element in B that are not in A. Element in B that are not in A. When it is in B, it's also in A. For it is in B, but it's not in A. So we'll write 4 and true. And that's how complement of a set or difference of a set, relative complement or difference of a set being done. Simple as such. Let's proceed to set basic operation. We have several set basic operation that we'll look after. We'll start with one, union of a set. Union of sets. Union of sets. What do this means? Given two sets, given two set A and B, the union is given as A union B. This is a sign for a union. A union B. Union. This is a sign of union. A union B. What did this union mean? Union mean it is a combination. It is the combination of all the elements in the set A and set B without repetition. For instance, let's look at a certain example here. We have a set A which has the following element: 1, 3, 4, and 5. The set B which have the following element: 2, 3, 5, and 7. Find A union B. From our definition of a union of a set, it is the combination of all the elements in A and B without repetition. So let's look this one. We have 1, we'll start with 1, 2, and 3. 3 is in both, so we'll just write 1 from our destination without repetition. We just write 1, write 3, and we proceed to 4, 5, and 7. This is the union of a set. That's how it's being done. Simple. And this was Roman 1 and Roman 2, and A union B. This N, from our previous video, this N means that the cardinality of a set of A union B. Cardinality is the number of element in a given set. Cardinality is a number of element in a given set. So according to this was set, we just count 1, 2, 3, 4, 5, 6. The cardinality of this set is 6. It's very simple. The next one, intersection of a set. Given by given that two set A and B intersection is given that A intersection B, this sign mean intersection. It's the opposite of that sign of union. Intersection N means intersection. A intersection B. Its definition: it is only the element that are in A and B. For instance, let's consider certain example here. E.g., we have a set A which has the following element: 1, 3, 4, 5. The set B are 2, 3, 5, 7. Find A intersection B, given that find A intersection A intersection B. Element that are in A, that are in set A and are in set B. According to this example, it would be 1 is only in A but not in B. 1, it is in set A but it's not in set B, so it's not an intersection. 3, it is in set A and also in set B, so we'll start with 3. 5, 4, it's only in the set A but not in the set B. 5 is only in the set A and B, so it will be only 3 and 5. Another example: given that T even number from 1 to 12, and common factor of 6, 8 and 12. Find T intersection N. We'll start by listing the element of the set T and N. Let's start with T. The element of the section, even number from 1 to 12. Start with 2, 4, 6, 8, 10, then 12. Because it was from 1 to 12. Then the element of the set N, common factor of 6, 8 and 12. Common factor is a number that can divide a number without a remainder, which is 2 can divide 6, it can divide 8 and it can divide 12. It's a common factor. T intersection and element that is in T and also in N. According to me, I think it's only 2. So 2 is the answer there.